Elements and compounds. Democritus was a Greek philosopher who first came up with the idea of atomism. He theorized that if you take an object and cut it in half, and then take one of the halves and cut that again in half, eventually you would be left with a single piece of matter that is so small it cannot be divided. He called this an atom, coming from the Greek word atomos, cannot be cut. The forms of atoms you've probably seen are elements from the periodic table, such as oxygen and carbon. If you were to take carbon, for example, you would be able to see that it has two elemental forms, graphite and diamond. Both of these would be considered carbon as an element, due to the fact that it is not chemically bonded to any other form of atom. On the other hand, if we were to take carbon dioxide, which you've no doubt heard of, we would consider this to be a compound, due to the fact that it is not carbon on its own, it is carbon chemically bonded to two oxygen atoms. It might be worth going over a few more examples of what is considered an element and what is considered a compound. Obviously, we just went over diamond and graphite, which are both elemental forms of the element carbon, but also oxygen in the form O2. Oxygen is an element. So is hydrogen, and finally sodium. These are all pure elements on their own. They are not chemically bonded to any other element. They are just pure forms of that element. On the other hand, compounds, such as carbon dioxide, are two or more elements chemically bonded together. Another example of this is water, which is two hydrogens chemically bonded to an oxygen. Another good example compound is common table salt, NaCl, and I've attached a YouTube video which I will also post in the description, which involves the formation of sodium chloride, NaCl, from pure sodium and pure chlorine. The reaction itself is pretty vigorous, and I thought it was worth checking out if you're interested. The final compound I will give as an example is methane, 4 hydrogens chemically bonded to one carbon atom. You may or may not have seen this compound before, but you will definitely see it a lot in the future if you are going to be studying chemistry. The main takeaway from this is that elements are comprised of a single type of atom, whereas compounds are two or more elements chemically bonded together. It should be noted that this chemical bonding of two or more elements changes the physical properties of those elements. For example, oxygen and hydrogen are both gases, but water is a liquid. And sodium and chlorine are both incredibly dangerous elements, but when they are mixed together in the form sodium chloride, they are entirely safe to eat. Next, I'll be going over a few example questions, and then finally an exam question on this topic. Here I have 4 elements or compounds. Please pause the video and answer. Okay, first up was ethene, which is a compound, a mixture of carbon and hydrogen. Then there was fluorine, which is an element. It contains only fluorine atoms. Then there was iron, which is an element, with the symbol Fe on your periodic table. And then steel, which is a mixture of carbon and iron, which is sort of a trick question. You wouldn't have known that unless you knew it. The introduction of carbon into iron changes the physical properties of the metal to make it stronger and more brittle. Here we have 2 drawings. Again, pause the video if needed. The drawing on the left is an element because it only contains one form of circle, and the drawing on the right is a compound because it contains the big white circle and the smaller red circle, both of these representing different atoms. Finally, here is the exam question we will be going over today. It is recommended you pause the video and try and answer each question, and then I will go over the answers for the questions after you have unpaused. Question 3a, part 1. Which diagram represents an element? Basically, this question is asking you, which diagram is composed entirely of a single element? And the answer is diagram D. It's the only diagram composed of a single element, that element being oxygen. This is a diagram of O2. Part 2. Which diagram represents carbon dioxide? Following the key, you can easily see which atom is carbon and which atoms are oxygens, and so it's a very simple matter of figuring out that diagram A is comprised of a single carbon atom and 2 oxygen atoms, meaning that diagram A is the answer. Part 3. Give the formula for the substance in diagram C. Following the key, it is relatively simple to answer this question. Understand which circle is representing which element, and then tally them up. So you should get the answer. There are 2 carbons, 6 hydrogens, giving the formula C2H6. Hopefully this video has helped you understand what elements are, as well as highlighting the difference between elements in their elemental states, such as carbon in the forms of diamond and graphite, and elements in compounds, such as carbon in carbon dioxide. Another takeaway from this video should be the change in physical properties when moving from elemental substances to compounds, such as the difference between very solid diamond and the gaseous carbon dioxide when carbon moves from its elemental form to its compound form. Hopefully you have enjoyed. Thank you for watching.